cable from switch isolated go to ST terminate, and then they go to the power block. They have 5 wires. 3 is three-phase, and then 2 is live electrical. The sizing of the cable is 4 mm square. The 2 go to the current voltage to change the current properties from high to low, and then 1 go to the voltage transformer, which is regulate the voltage from 415 voltage to the nominal voltage is 400, and then they go to the power output.
Why we need to have that?
This
Yeah. How it regulate?
it regulate from 0 to 400.
Then increase slowly.
And then go to the power output. Okay. So for the power output, we have 3 cables, which is the sizing is 2.5 mm, and then we have a grounding. The face connect to the BZT. That's all for
Thank you
me.
very much. Next.
The alarm and the lamps. The cable is for this one. So connected to RG. If the show the green, that is the access to open. If the show is the red light, the automatically relay door is the close.
And then when the from here, meaning high voltage operation can start here. And then if we open the door, and then for the emergency button, also use the same button. Normal condition, stop button. Okay, for IC and transformer and secondary part, we use the magnet to connect the grounding system. This grounding switch can withstand 150 kV and it operates at 24 volt and 50 or 60 volts. And for the we intend to implement the rope. We drag the rope about 20 millimeter the rope to the ground. Okay, for the adjustable, we need to measure the resistance is below than 2 ohm. And then the current can to the ground. And to get the 2 ohms, we need to parallel second rope 10 meter from the first one. And if we still not get the 2 ohm, we will need to repeat the process until we
Generation and for supply to DC and generation. So this is for like 100 kilovolt and 220 volt. And then rate current 220, 0.09, and then going to 50 to 100. So we move to the side from the recipe output. We use the cable 2.5 mm, which include 3 cross wires, which is despite 2 phase wires connect to the PZT, and grounding wires connect to the cooler. And then the concept of PZT is gradually step up from the nominal voltage until the reach higher voltage such as 1 kilovolt. Okay? The reason why cannot be directly the higher voltage into PZT is because the equipment can be damaged. Then for the connection, we can see the connection for the series, the connection is 2 PS and 1 PU. Meanwhile, the parallel 1 PS, 2 PS and 1 PU, 2 PU. So for the series connection, if we injection 100 kilovolt, will be the series connection will be full potential of PZT, and meanwhile the parallel connection can be half of potential PZT. That's all for me.
Next, part B. Part B.
So part B, we have the component. First component, grounding switch, pedestal, measuring capacitor, electrode, balancing cup, impulse.
Nampak lawan yang kita ni? Simple. Tapi ya, kita buat tapi ya. This is the banana cable and the connection to the bangasi. Little bit on this capacitor. This capacitor and that capacitor can be why we have to have these two things?
Why we have need measuring capacitor and secondary capacitor? Because the measuring capacitor and secondary capacitor form a precision capacitive voltage divider system for high voltage measurement. The 100 PF primary capacitor being significantly smaller minimize circuit loading while sampling the high voltage signal. The secondary capacitor establish a fixed division ratio, safely reducing the measure voltage to instrumentation levels. This carefully calibrate ratio maintains measurement accuracy. The capacitor pairing is specifically designed to preserve fast impulse characteristic with the 100 PF value selected to maintain proper high frequency response and the 2 microfarad value ensuring stable signal conditioning for accurate data.
So I remove this one. Then what will happen?
If a transformer in open condition, no load connected to the secondary winding, a significant voltage will be induced across the secondary terminals. This can be dangerous, causing electric shock and potential damaging the transformer insulation. This voltage can be very high, potentially reaching dangerous level. When the
Very last one. This is open, right?
yes.
And then I put these things here on top of this electrode. Then what will happen?
And then if we put something on the top of PZT, there will cause arcing and will be corona effect.
What is the potential of the grounding? What is the potential of the grounding?
The grounding system should ideally have a potential of 0 volts to ensure safety, provide a stable voltage reference and offer a low resistance path for fault current.